As in most ancient cultures, astronomy was actually practiced as astrology. Astronomical events, whether they were everyday occurrences or rare incidents, had deep religious meaning for the people. It was believed that all things happen for a reason. This spiritual angle often spilled over onto the social or political levels as well. Kings and nobles relied heavily on omens which were witnessed and interpreted by a powerful group of priest astronomers. Lives were lived according to the advice of these astronomers who seemingly were able to understand the universe and make predictions based on their observations. They had a rich religious tradition which permeated every aspect of society. As in most early cultures, the patterns and behaviors of the sky led to the creation of a number of myths to explain the astronomical phenomenon. For the Egyptians, the practice of astronomy went beyond legend. Huge temples and pyramids were built to have a certain astronomical orientation. Although many of the religious aspects of the Egyptian life were known for centuries, it was not until recently that a number of archaeoastronomers attempted to find out how important astronomy really was in Egypt. The Stonehenge was more than a temple. It was an astronomical calculator. It was argued that the summer solstice can't be accidental. There must have been fundamental to the design and placement of the Stonehenge. The Chinese people tended to use astronomy for practical purposes from the very beginning, unlike many of the other cultures studied here that focused mainly on religious aspects of the sky. However, they did develop an extensive system of the zodiac designs to help guide the life of people on Earth. Their version of the zodiac was called the Yellow Path, a reference to the sun traveling along the ecliptic. Like in the Western astrology, the Chinese had 12 houses along the Yellow Path. Thales has been credited with the discovery of 5 geometric theorems. 1. That a circle is bisected by diameter. 2. That angles and triangles opposite two sides of equivalent length are equal. 3. That opposite angles formed by intersecting straight lines are equal. 4. That the angle inscribed inside a semicircle is an A right angle. 5. That a triangle is determined if its base and the two angles at the base are given. He was the first person to claim that the Earth was a sphere, a very simple view of the universe, and also the first person to recognize Venus at night and Venus in the day are the same thing. The major breakthroughs of the Babylonians was their invention of the degree system to distinguish positions in the sky. The system was similar to ours use of degrees to calculate latitude and longitude. The Greeks adopted the degree system and also many of the Babylonian constellations, which they renamed in Greek. The great philosopher proved that the earth is spherical and believed that it was at the center of the universe. His reason for believing this was actually quite scientific. He knew that if the earth revolved around the sun, then we should see stars shift position throughout the year. Since he did not have the technology to detect this shift, as we do today, he concluded that the Earth must rest at the center of the universe. According to him, the sun, planets, and stars were located in spheres that revolved around Earth. He was the first to put forward the idea that the sun is actually in the center of the universe. His theory was considered far too radical. Unfortunately, history tends to forget that he came to this conclusion about 1,750 years before Copernicus did. He also attempted to measure the relative distances between the Earth and the Sun and the Earth and the Moon. Even though he used a reasonable method, his results were not very accurate because he lacked the technological equipment to make a precise measurement. He studied astronomy, geography, and math. He is the most famous for making the first good measurement of the size of the Earth. He spent most of his life in the city of Alexandria, Egypt. Galileo developed the first complete telescope. He discovered that the moon had an uneven surface and that the Milky Way was made up of numerous separate stars. In 1610, he discovered the satellites of Jupiter. He discovered the oval shape of Saturn and the phases of Venus and the spots on the sun. Isaac made many theories of gravity and its effects on astronomical objects. He also made a theory of heliocentrism. He discovered a great deal of calculus and published a book on it. Soon became a mathematics professor and made a theory called Newton's theory of color, which shows how hard it is to change a light's color. He died on March 31st, 1727. Edmund Halley was an English scientist who is best known for predicting the orbit of the comet that was later named after him. He made discoveries in geographics, mathematics, meteorology, and physics. In 1716, he discovered a method for observing transitions of Venus across the dish of the sun in order to determine the distance of Earth from the sun. He proposed two types of diving bells for exploring underwater, and in 1718, by comparing star positions with data recorded by the Greek philosopher Ptolemy, he deduced the motion of the stars. He died on January 14, 1742. The Sun, the Moon, Venus, and specific star clusters and constellations were most important to them. These objects were given the most attention by the priest astronomers who spent generations finding the precise paths of these objects across the sky and through the seasons. The most important objects in the sky is the Sun, which is universally recognized as the prime life giver on Earth. The Moon was another object of interest to the Mayans. They recorded and interpreted every aspect of the sky, and they believed that the will and actions of the gods could be read in the stars, moon, and planets. He made an accurate observation of the brighter stars in the sky without a telescope. This info passed to Kepler, his assistant. A Greek astronomer and mathematician who made fundamental contributions to the advancements of astronomy as a mathematical science and to the foundations of trigonometry. He is ranked among the greatest scientists of antiquity and is very little known about his life. Only one of his many writings is still in existence. Knowledge of the rest of his work relies on second-hand reports, especially an astronomical compendium, the Almagest, written by Ptolemy in the 2nd century A.D. As a young man in Bithynia, Hipparchus compiled records of local weather patterns throughout the year, and Hipparchus spent most of his adult life carrying out a program of astronomical observation and research on the island of Rhodes. Hipparchus recorded so many observations that he published an annotated list of them. When Copernicus thought of the theory, the calendar was out of step, and the lunar orbit had the moon's apparent size changing when it didn't. Ptolemy's Earth-centered universe was in place. This was why Copernicus tried to prove how the universe really orbited. Copernicus started out by relocating the sun. When he centered the sun, he started mixing planets up, and he stated that the Earth was the third farthest planet from the sun. Discovered the general theory of relativity in 1915 and is best known for the mass and energy equivalence formula E equals mc squared. In 1921, he got the Nobel Prize in Physics in 1921. He's famous for his structure of the atom in 1913 and proposed a theory for the hydrogen atom. In 1925, he introduced the quantum numbers and developed the Pauli principle, that any two electrons in an atom can't have identical sets of quantum numbers. Protons and neutrons in the nucleus also have quantum numbers. He developed the theory of quantum mechanics, published in 1925, and he later stated his principle of uncertainty and the position of momentum of a mobile particle has errors. In the 1920s, he showed that many distant, faint clouds of light were actually galaxies. The Milky Way wasn't the only galaxy, and in 1929 he determined that the farther a galaxy is from Earth, the faster it appeared to move away. That formed the basis of the Big Bang Theory, and the universe started as a single intense burst of energy and has been expanding ever since. Also developed the Big Bang Theory in a paper published in 1931. In 1927, he published a paper that had a solution to the equations of general relativity that went unnoticed. He separated nuclear motion from electronic motion in the mathematical treatment of molecules. He's credited with being a founding father of the American School of Theoretical Physics, and in the 30s he was the first to describe what we can do with black holes. He's also the father of the atomic bomb. He contributed to the theory of stellar nuclear synthesis. He resected the Big Bang for a steady-state universe. He was born on June 24th, 1915. He theorized that rare elements could be explained by supernovas, involved in the anthropic principle that constants of physics and chemistry are just right for us to exist. It's here for us to observe. This work caused him to start believing in the guiding home of a god when he considered the statistical improbability of the large amount of carbon in the universe. Holmdel antenna Penzias knew would make a great telescope, so when they started to use it, they noticed there was a background noise. Live static in the radio was the same in the microwave range, coming from every direction. They thought it was coming from the telescope, which wasn't unusual, but wasn't the case. There was no other interference from New York or radiation from our galaxy or extraterrestrial radio signals. They even removed the pigeons living in the antenna. They contacted Robert Dick, who had said, "What if there was a Big Bang? Then residue from the explosion should by now have a low-level background radiation throughout the universe." Wilson didn't like this, but he published it as just the facts. Armstrong was the first man to walk on the moon on July 20th, 1969. He was an engineer, test pilot, astronaut, and admin for the NACA, flown over 200 different models of aircraft, and was a command pilot for the Gemini 8. Buzz Aldrin was selected by NASA for the next Gemini 12 mission in 1963, and in 1969 he and Armstrong walked on the moon.